Although not listed in the current Motorola DALT collaboration template, we decided to continue the work on the project entitled Self-Guided Robot using SONAR with the Motorola EVM. The project team Daniel Brosteanu and Lucian Muntean approached this application as a straightforward development of the SONAR-based project successfully finalized last year in collaboration with Motorola. The goals were to develop a mini-robot using the DSP-56824 EVM, able to move autonomously towards a given target on a flat floor, avoiding obstacles on its way by using a SONAR device.
Now I present the self-guided mini-robot we made. As you can see, three main parts compose it. The DSP-56824 is the core of the mini-robot, which run the main program and all the subroutines run on it. It will receive the coordinates, determine the distance to the first obstacle in its way, create a proximity map, and control the motors. This is the user adapter board with the following functions: amplification of the analog signal received from outside, adaptation of the command signals and current from DC and stepper motors, analog to digital signals conversion. Mechanical platform with the purpose of supporting the motors and the two other boards. Now I'll present the hardware modules. The most important module is the SONAR. It is composed of two ultrasound transducers mounted on a mobile platform driven by the stepper motor. These are the amplifier circuits from the emitted and received signals. Near the receiver amplifier you can see the analog to digital converter. This is the infrared receiver module, implemented with specialized circuits. These circuits represent the power module used for adapting voltage and current for the DSP, the SONAR module and the motors. The driving motors of the mini-robot are DC motors with torque reducer. Now I'll ask my colleague to explain how the system works and to perform a practical demonstration.
The main software modules of the application are SONAR routine used to detect objects and calculate their distance related to the mini-robot by emitting or receiving ultrasound waves, movement routine useful in mini-robot movement and SONAR platform orientation, and infrared routine which implements the software communication interface between the user and the mini-robot. The main control routine has the task to receive the new coordinate from the user and to move the mini-robot onto a calculated path by creating the proximity space map and searching for the minimal route. Now we exemplify the mini-robot operating procedure. The first step is to send the target coordinates. These relative Cartesian coordinates, composed of 3 digits for the x part and 3 digits for the y part, are expressed in centimeters and sent using a remote control. For example, we will take the following coordinates: 300 centimeters for the x-axis and the same for the y-axis. After the last digit is received by the mini-robot, it will start to orient towards the new direction. Next, it will create a proximity space map and will search for the minimal route. Because of the absence of the objects, it will move forward with one step, which is 80 centimeters long. Further, it will recalculate the target coordinates and test if its distance from the target is acceptable. This distance, for practical reason, is set to 100 centimeters. When it reaches the target proximity, the mini-robot stops and waits for the new coordinates.
Now I'll make a second demonstration with our robot in a real work area populated with some obstacles. The mini-robot must reach the destination point, avoid the obstacles and find a shortest way. In this moment I introduce the destination coordinate 400 to X line and 300 to Y line. And we watch now the mini-robot and its movements. As you can see, the robot stops near the destination point. The movement is precise enough to do with the mini-robot some elementary work, such finding a right path to the target in the populated area. The velocity of the mini-robot is high enough to accomplish a real-time job, like transporting a reasonable weight from one point to another. A very smooth surface causes problems in robot movement. The wheels slip and lose the rotation precision.
The application can be further enhanced by implementing a bidirectional infrared communication link between the Minirobot and the remote control system. Also, mounting position transducers on the driving wheels and improving sonar performance will boost the robot moving precision and its ability to find the targets with more accuracy.